Welcome back, Contemporary Math. We are in Chapter 5C, Statistical Tables and Graphs. And so in this section, we're going to talk a little bit about frequency and do a little bit of frequency tables. We're going to talk about the different types of data there are. We are going to do some bar charts and pie graphs and some histograms and some time plots. Okay. So let's start out with frequency tables. So if you think about frequency is how often something happens. So if we consider these results for a class of 20 students, so these are the results of some sort of exam that they took. If we look at this data is like really kind of hard to read. You wouldn't want to read this raw data up here. So a better way to maybe look at this sort of thing is to get a frequency table. So what is a frequency table? We count the number of A's. So hopefully I counted my A's correctly. This should be 1, 2, 3, 4 A's in there. There should be 5 B's. There should be 6 C's, 3 D's, 2 F's. And if we count all these together, there should be a total of 20, what we're expecting, because there are 20 students total in here. Okay, so this is a basic frequency table. There are 2 variations on frequency that the book likes to talk about. Ooh. Oh, here they describe the frequency table. Sorry. So I thought we were going somewhere else. But a basic frequency table has basically two columns. First column lists the categories of data, and then the second column lists the frequency for each of those categories. So on the category of A, we had that thing 4 times. On the category of B, we had that thing 5 times, and so on. Okay, so the other 2 things that they like to talk about that are extensions of frequency, as they say, 2 variations on frequency, is relative frequency and cumulative frequency. So we talked about relative difference. And so when you talk about this word relative, you're comparing it to something. So you want to think about like part to whole, right? We're dividing the part by the whole, sort of here. We did relative change, we did relative difference between 2 numbers. So this is kind of similar. We're dividing 2 things here. So the frequency here is 4, but we want to take 4, the part out of the whole, which is 20. So 4 out of 20 would give me 20%. 5 out of 20 would give me 25%. 6 out of 20 would give me 30%, and so on, right? So this would be the relative frequency. The next thing that they want to talk about is this thing called cumulative frequency. And it's the number of responses in a particular category and all the preceding categories. So what we're going to do is we're going to take 4. That is all we have here. When we get to the next step, we have 4 plus 5. We have A and B that we want to count for. So this one should be 5 plus 4 or 9. If we get to here, we have A plus B plus C. If you want to do 5 plus 4 plus 6, that's good. You've already figured out 9 from the previous one. So really what we got to do is just add 6. So 9 plus 6 should get me to 15. 15 plus 3 should get me to 18. 18 plus 2 should get me to 20. And I'm at 20. I'm not adding anything for this total line. It stays at 20. So you might notice there's a bit of a repeat there. And there should be when you're doing your cumulative. That last step, we're not going to add anything. Okay. The next thing the book really wants to talk about is this thing called qualitative versus quantitative data. So qualitative data consists of values that can be placed into non-numerical categories. Qualitative data represents count or measurements. So if we're looking here, we know people scored an A, but we don't really know like what their exact score was. So if we look here, I would consider this to be categorical. If they gave us an actual grade number, I would consider that to be quantitative. Okay, so we want to classify the following as qualitative or quantitative. And I think most of these from the definition, if we can put it in a group or a category, it is going to be qualitative. If it is a number that we can crunch on, we can find averages, it's on some sort of scale, then I would consider it quantitative. And so if we look along these examples, I agree with the book and what they're saying in most of these. There's one of these examples, which is E, which I really don't agree with what the book says. I would not classify it the same way they're classifying it. I'll talk a little bit in a second. But flavors of ice cream, if we want to classify that, you're going to give me words for the flavors of ice cream. You're not going to give me numbers to represent flavors of ice cream. So right away, if you're giving me words, those are categories, right? Chocolate, vanilla, strawberry, those are all categories of ice cream. So this would be qualitative. The volume of ice cream in a carton, you're going to give me a number. We could put that number on a scale, it would make sense. And we could find the average of that number, so I would definitely consider that quantitative. Okay, so now we want to talk about your social security number or your bank card. So my social security number is 1, 2, 3, 4, 5, 6, 7, 8. No, it's not. But you have your social security number. So yeah, I can take everyone's social security number out there. Would it make sense if I put this on a scale? I put that on a scale. But would it make sense if I put it on a scale somehow? Would it make sense to put social security numbers on a scale? Would it make sense to take average of these? So we are using a number here, but we're not using a number like it's a number. We're using a number sort of like it's a category here. So this represents a sort of category. It's a category with one thing in it. It's a category with you in it. So pretend this is your social security number. And so this is a category, and it's a category that represents one person. So it's not a big category. But each of these things it's just sort of like a name, right? And so whether we give you a number, whether we give you a name, this would be qualitative, this would be qualitative. They're not actually representing, this is not representing something numerical, right? It is a number, but it's not representing something numerical. It doesn't make sense to put it on a scale. It doesn't make sense to take an average of it. So these are things that I would definitely call qualitative. And just as your social security number is a qualitative quantity, which tells me what person I'm talking about, the bank card is also a qualitative quantity, but it's telling me what bank account it's talking about, right? So both of these I would consider qualitative numbers. You're not going to take an average. You're not going to put this thing on a scale somehow. I mean, you can, but it's not going to make sense, right? All right, so now we get to this thing. And this thing says the star rating system on IMDb, which ranks movies from 1 star to 10 stars. Great. If I were answering this, I can go from 1 star to 10 stars on the scale. I can average those things and find the average score for a movie. So this is what I would say. I would by all means call this quantitative. I would treat this like a quantitative variable. I would do the calculations on it just like it's a quantitative variable. The book, and here's what the book says, and here's their reasoning, and I will talk about what they say, but I don't particularly care for it. I don't know if I really agree with what they're saying. It does not follow from their definition. They didn't define things well if they did this correctly. So from the book definition, what it definitely sounds like is that if you can put it in non-numerical categories, it's quantitative. If it's a measurement, then it's quantitative. So they say, and they introduce a new word that they didn't even use in their definition. They say that it is subjective. And since it's subjective, it's not a measurement, but I'm not sure I agree with that, because you can have subjective measurements. That's what this is to me. But they're either saying something that's blatantly wrong in the book, I'm not really sure, or they're saying something that is totally misleading from like what I would do in higher statistics. So I would not worry too much about this. And by all means, I would consider this quantitative. And if this is a point of contention that you're like, why are they considering this qualitative? I don't really know. Their reasoning doesn't make a whole lot of sense with the way that they're defining things. I think maybe that they're saying they're ranking the quality of the movie, and maybe that's why it's qualitative. But the way and the metric that they put on this thing to rank it would absolutely be treated like a quantitative variable. So, with that said, I don't always agree with the way that they do things in the book. When we deal with quantitative data categories, so if you want to categorize data that is numerical, you can put them in things called bins. So what we're going to do is we're going to put them in ranges. So we're going every 5 numbers here, I believe, from 90 to 94. You have to include the 0, so 90 plus 91 plus 92 plus 93 plus 94. There are 5 numbers in there. Okay. So now we want to make a table. We want to make a table with frequency, relative frequency, and cumulative frequency. And so I give you a little bit of a head start, but if you don't know anything else, if you know this is a class of 25, you can always put your totals down. So your frequency total should be 25. Your relative frequency is a percentage, so this should give you 100% of whatever the heck you're doing. Your cumulative frequency should be 25. Okay. So now if we're looking along here, we want to look at everything that is between what, 95 and 100. So we get 1, 2, 3, 4, 5, 6, 7. I believe there's 8 total things. If you want to start from the bottom up, you can do that as well. We can start down here, look at numbers between 70 and 74. That might be easier for some people. But we want to go along here. And I'll give you just a little bit of time to do it. To go ahead and count out all these frequencies. You should be able to count every number between 90 and 94. You get that there are 4 numbers between there. Between 85 and 90, there is 1 number between there. Between 80 and 84, we get 2 numbers. So 95 to 100, we include the 95, we include the 100. And 90 to 94, we include the 90. We are including the endpoints on these things, right? And 75 to 80, we get 5, and we get 5. And I don't want to rely on my eyes to make sure I got every last single one. So if I want to double check this, if I want to do 8 plus 4 plus 1 plus 2 plus 5 plus 5, I should be getting 25 total. Okay. So you might have noticed in the previous one, we had 20 total. And I think if we wanted to get to 100%, we just multiply our numbers by 5 to get here to here. We could do maybe another cheap trick here. If we want to get to 100, we got to multiply these things by 4. So if you were to do relative frequency, I guess we could do it the old school fashioned way. We could do 8 out of 25 would be the more proper way to do it. But this should get you, I ain't got much room here, so I'm going to try to squeeze it in, 32%. This should give me 16%. This should give me 4%, 8%, 20, and 20. So another way I can do it maybe is just by multiplying by 4. If you get a really nice base like 25 or 20, right? You might be able to do little tricks like that. But if not, we know how to find relative frequency. It's the part over the whole. So if I do 32 and I add 16 and add 4 and I add 8 and I add 20 and 20, I should get 100%, which I do. Okay, and now the last thing, the cumulative frequency. So now we're ignoring this middle part. Can I ignore it for a second? So now we're not even looking at this column. We're just doing cumulative frequency. So here I have 8. I have 8 plus 4 should give me 12. I have 12 plus 1 should give me 13, sorry. 13 plus 2 should give me 15. And I got 15 plus 5 should give me 20. And then 20 plus 5 should give me 25. So I'm just adding subsequent numbers, right? Okay. So that is all about frequency tables. So hopefully we can get down making frequency tables, relative frequency tables, and cumulative frequency tables. The next thing we want to talk about is bar graphs and pie charts. So they give us a list of things that are important for your graph. So the important thing really is to remember your titles, the overall title, your axis titles, and then the other thing is your scale. Make sure you're making your scale appropriate, your vertical scale, your horizontal scale. And then if you have to, if you don't have your categories properly labeled, you might need a legend in there. So a few examples. A bar graph uses a set of bars to represent the frequency or relative frequency. So whether we do frequency or we do relative frequency, you might notice we're getting a very similar sort of picture here. So this is going back to that first class we talked about of 20 students. Reason that example, but this is their grade distribution with their frequency. This is their grade distribution with their relative frequency. All right, so we want to do a pie chart. Pie charts are used primarily for relative frequencies because the total pie must always represent the total relative frequency of 100%. So if we're doing pie charts, those percentages did not come out very well, but we know what they are from a previous example. So if you have to go back and look at this table, this is the table that I'm using. So A should be at 20%. Is that what it is? Yep. Sorry. A is the blue one. It looks like it's at 20%. C is this one that's at 30%. So with this said, I think this one is 25%, right? So if we think about 25%, if we do 25% of 360, we're going to get 90 degrees or a 90-degree angle. So I know if you're making a pie chart like on a test or somewhere like that, there's a good chance you may not have a compass. This is sort of what I'm going to look for. Like, is it look pretty close? If 25% is giving me a right angle, a 90-degree angle, or if I do 0.25, right, times 360, I'm going to do a quarter of 360. It's going to give me 90 degrees. So if it's 25%, it should be a quarter of this triangle. Sorry, not a quarter, quarter of the circle. That's what I meant to say. It should be 90 degrees. It should be a quarter of the circle. If it's 30%, which I believe this is right here, it should be a little bit larger than 90. It should be an obtuse sort of angle happening in here. We could calculate it as what, 30% of 360. I think it's going to give me like 108 degrees. So if I really wanted to calculate these things, I could calculate these things. And it might be good to sort of give me an idea of what these things look like. If I want to do 20% of 360, I'm going to get 72 degrees. But the main thing is that 25 is giving me 90. If I go a little bit below 25, this is a little bit less than 90. If I go a little bit over 25, right, that is a little bit more than 90 degrees. So you may not be getting these things exactly precise, but they should at least be where your 25% looks like it's about a quarter of the circle. If it's a little bit larger, it looks a little bit larger than the quarter. If it's a little bit smaller, it looks a little bit smaller. It should be approximate, right? I'm not expecting things to be exact. Where am I? Oh, did not take out the page. There we go. I had to reprint this one. There's some crazy spacing that happened on here, but I think I fixed it. All right, so now we want to create a bar graph for this thing. So the following table shows the total annual electricity consumption in kilowatt hours and per capita annual electricity consumption in kilowatt hours per person. Make bar graphs for the total annual electricity consumption kilowatt hours and per capita annual electricity consumption kilowatt hours per person, put the bars in descending order of size. So we want to make a bar graph. So one of the first things we really need if we're going to make a bar graph is a title. And I try to stagger them a little bit. This one's going to be my annual electricity consumption, trying to give us enough space to write in the labels and write in everything without these graphs crashing into each other. So annual electricity consumption is going to be this one. This one is going to be per capita. And electricity consumption. And now we want to talk about our scales. So if we look at this, this is thousands, millions. We are in billions. This goes up to 6 trillion. So you might have figured this out, but we're going to need our y-axis. This is going to go along our y. This is going to go along our x. And you can change those technically. But typically, I really like my categories to go along here, and I like my bars to go up and down. That's just something that I am more used to. I think it looks better personally. It's easier for me to read just because I've done it more so that way. Personal bias there, but I want to do here the country. And if I'm doing my country on my x-axis, which is the group, my bars are going to go up and down. So I got to think about what units this is going to be in. So this is my y variable. And if I'm going up to 6 trillion, and I think I have a half, this is about a half trillion here. Then I need to do this in this is going to be my electricity in kilowatt hours in trillions. So I'm going to do my y-axis in trillions. And if I do it in trillions, so I need to get up to 6 trillion. I think I'm going to count every 1, 2, 3, 4. I think I'm going to do, let's see if I got enough room to do this. Okay, so I think we're going to go by a half trillion each time. So here, I think I'm going to go a half trillion. This would be 1 trillion. This is a half trillion, 2. The half trillion. This one would be 3 right in here. This would give me 4. This give me 5. Skip 1 right here would give me 6 trillion. Okay. Now I want to do these in descending order. So right away, maybe take note, these are already in descending order. So I just need to write these in the right sort of direction. So right here, I have China is a little bit over 6 trillion. Not quite 6.5, right? So if I want to do a bar for China, I'm bringing it up a little bit over the 6, not quite to the 6.5. So I draw my bar. And I'll go ahead and shade my bar in. And I'll put my axis label of China. So that one represents China. I might have wrote country too soon. I probably should have wrote it further down here. But the next one I look at is the US. And we're not quite at 4 trillion. If I want to do the US, I should really put a gap between my China bar and my US bar. So if I'm doing categories, I usually put a gap between my bars. So this is not quite 4. And this is the US. I'll shade in my bar. The next one is right at about 1.5, and that is India. So now I'm coming here. I want to draw India in here. And it's like right almost at 1.5, a little bit over. I think I might have just enough room to write. Definitely make sure you make yourself enough room. So that is India. We have US, India, we have Russia. Right next is right about 1. Russia. And the next one I have is Japan, which is right below 1. So Russia was a little bit over 1. Japan should be a little bit below 1. We have Germany, which is about a half. Canada's about a half. And Brazil's about a half. Each of these, this is what. Where we at? Germany is next. We got Germany, we got Canada, and Brazil. So this would be the annual electricity consumption. And so we have electricity in kilowatt hours and trillions of kilowatt hours. All right, so now we want to look along here. I'm going to have the same thing. I'm going to have my countries down here. Over here, though, it is going to be electricity. And we're still doing kilowatt hours per person. But this is going to be in what? Now it looks like we're going to the thousands. So it's important to put what unit we're in over here. So if we're going in thousands, it looks I need it from 1 to 12,000. I think if I go every 2, that give me enough space. Let's see. No, I don't think I have enough tick marks. That would require 24 tick marks, and I ain't got enough. So I think I'm gonna have to go every 1. So this is 1,000, this is 2,000, 3,000. Every tick mark is 1,000, 4, 5, 6, 8. This is 10, 12, 14, and 16 up here. So my numbers are kind of running into my words a little bit. Probably should have planned that a little bit better. My graphs are kind of close together and they're crunching in on each other, but every tick mark is a number. So if we want to start with the largest one. So if we look over here, which one is the largest one? I believe Canada's coming in first, right at 15. Come up here, we should be looking at 15 as this number right here. So I want to fill this in and I want to call this Canada. So Canada is close to 15. It's right below it. The next one is the US, which is right at 12. Go here, skip both space. A little bit of gap between Mars. Here at 12. I'm going to shade this thing in. Call this the United States. All right, the next thing I have 14, 12. Looks like the 7s are next. So Russia and then Japan looks like it's right behind there. And then Germany. So that's 7, 1, 2, 3, 4, 5, 6, 7,000. About halfway to the 8, maybe even. I want to shade this in. This one is Russia. The next one's Japan. It should be right under that at 73. I'll shade that in and I call this Japan. The next one is Germany, which is at 66. So about halfway to the 7. And this is Germany. All right, so we got 3 more that we need to do. I believe they are, where am I at? China is next, and then Brazil, and then India. So China has 44.75. That's almost 5. 1, 2, 3, 4. 1, 2, 3, 4. That was 5. Right past the 4, not quite the 5. Right in there. Shade it in, and I call this thing China. The next one is Brazil at 25. So that's between what, 2 and 3? That's 1, 2, right between the 2 and 3. I shade it in, and I call this guy Brazil. And the last one that I'm looking at is India, which is right above 1,000. I draw it and I shade it in. This is India here. And so I'm labeling this axis 1 by 1. Each line represents 1,000. So you have to make sure your scaling is correct, right? You have to make sure we're getting up to 12, up past 14, up past 15,000 probably. You should make sure it's numbered, and you should probably make sure your numbers aren't crashing into your letters, but there wasn't much room on here. So Hopefully we will provide. So I'm looking at this one now. I did my bar chart. Now I want to do a, did my bar graph. I want to do my pie chart. So Half Baked Bread Company sells 4 different breads. Baguettes are 30% of the sales. The brioche is 25% of the sale. The ciabatta is 25%, and focaccia makes up 20% of the sale. Construct a pie chart to represent the bread. So our baked goods do not discriminate against each other. We can use a pie chart to represent bread. But here we go. The thing that I would start off with is these 25%. If we do 25% of 360, that's going to give me the 90 degrees I was talking about. So if you want to do a 90-degree angle right there, I believe, what is this? Brioche is the first thing that they say. So if you want to put your label in here, that would be fine. There's plenty of room in this circle. And you should definitely put your percentage. The other thing they give us is ciabatta is also 25%. So these things should be even quarters. If we put them together, they should give us half the circle. They're giving us 50% of the circle. And so maybe one of the first things you should do is find the center of your circle in order to be able to draw these segments, right? So we do need to find our center of the circle. If we want to do it in quarters, we make a 90-degree angle. If we want to do half, we draw that line down the center of the circle. That should give us half the circle. And then the other thing is what we're doing 30% of 360. And I'm doing what, 20% of 360. So if I do 30% of 360, that's giving me that 108. And if I do 20% of 360, that's giving me what, 72. The main thing is that you don't draw them evenly, right? One of them is a little bit bigger than the other. Which one's a little bit bigger? The one that's 30% is a little bit bigger than the one that's 20%. So I'm not going to grab a compass and like go measure these things. As long as they look pretty close, I'm going to be okay with it. And for the most part, if I'm doing this, I'm not going to be graphing. If someone assigned me to do this, I'm not going to graph this by hand, right? I'm going to use the technology to graph this. I'm going to use, what is this, Focaccia. I'm going to use probably Excel to graph this thing. Okay, so with that said, you need to put titles in this thing, right? In the previous one, they did not put the title within the graph, right? So what did they do? That was where they created a legend. So they created a legend, a color-coded legend. Oh wow, these like percentages came out way better for some reason. Don't know why my printer decided to change its tone between those two things, but there you go. They have a key, a color-coded, key. So A is dark blue, B is red, and so on. So one way or another, you have to tell me what the categories are. Okay, so on this one, they tell me with the legend. If you don't want to write a legend and you have a big enough circle, you could potentially just put your labels in there. If you don't have enough room. So let's say I didn't have enough room to write Focaccia right here. This one is too small. Well, let's make sure I spelled it right. Focaccia. Right there, you can put a little line saying, hey, that one is Focaccia. So some way, you're going to have to tell me what the category is. The other thing you should have is the numerical quantity it represents there. So that represents 20%. we should be putting the 20% up in there. Okay, so we have talked about most of the stuff that is kind of going to be new here. This histogram is basically a bar chart where your x-axis is a number. So, or it's a quantitative category. The bars have natural order and the bar widths have specific meanings. So when we look at our previous examples, like this, I separated my bars. So when we get to histogram, we're not going to be able to separate our bars like this because the x-axis is a numerical scale. So here, this was categories. So we have different categories, we have different countries. So when we start putting a numerical scale down here, we're going to start calling those things histograms. And they are still bar charts. But if we notice the width of these things, I just went 2 tiles, and I went 2 tiles mainly because that's how much room I had. That's what was convenient. And it looked pretty, basically. All right. And I kept them all, 2 tiles in width. So each one of these bars is the width of 2 tiles. What does the 2 tiles represent? It doesn't represent anything. It just represents what made it pretty. When we get to histograms, the width of our bar is going to actually represent something very specific. It is going to represent a range of quantities. So if we look at a line chart, they want to talk about histogram, they want to talk about a line chart, and then the last thing we're going to talk about is a time series graph. So a line chart is really easy to get if we draw a histogram. All we're doing is putting points, the same place where our histogram would be, and we're connecting the points. A time series graph is either a line chart or histogram, or your x-axis is the quantity of time. So these are very specific sort of examples of what histograms might look like, or what bar charts might look like. Okay, so in example 5, they want us to make a histogram and a line chart to display the test scores from the class of 25 students given in example 2. So going back to example 2, we are talking about this data happening here. And so what I'm saying is I want to graph the frequencies from this table. So I want to graph the frequencies. These are going to go on my y-axis. These are going to go along my x-axis. Okay, so we want to make our x-axis numerical. And if we look at our x-axis, it should be going from 70 to 100 in intervals of 5. If we look at our y-axis, the largest it is 8, the smallest it is 1. So I think if we go every 2, I think we'll have enough. 1 and 2. Label this. This is my frequency. This down here is going to be my grade. That's my test distribution for the second class. And so a little bit about this. So technically, you should start at 0 on both of these, and you should not really be making breaks You definitely don't make a break on your y-axis, but if you have to, what we were doing is we are making a little break. So sometimes they draw a little squiggly to represent the break. So now I want to go from 70 to 75, from 75 to 80. So I think if I do every two of them is going to be worth 5 points, 70 to 75 to 80 to 85 to 90 here, to 95 here, and then the topmost grade I can get is 100. And so if I look back at the quantities, between 70 and 74, there were 5 of them. So between 70 and 74 is here. I want to represent there were 5 of these things. So my bar should look something like this. And so there's my bar from 70 to 75. The next one is also 5. So this one is also getting a bar right here that is 5 in height. This represents every number from 75 to 80. Now we want to go from 80 to 84 is what we're going from right here. There are 2 of those. So we're going right here at the 2. We're going from 80 to 84, and we're coloring in our bar. Next one is from 85 to 90. There is 1 of those scores. So we are coloring in our bar for 1. There are 4 that are between 90 and 94. So we're going here at 4. And then the last one is between 90 and 95. There are 8 of them, which is way up here. So this does not look like it may have been the best test. A lot of people scored 100. Usually you expect everyone to be around the 70 mark and to kind of fall on both sides. Sort of normal distribution about the 70. But that is not what we have here. And so this is a histogram. And then they've talked about the width of these bars means something. So if we look at the width of these bars, they represent 5 numbers. 70 from 74 is what this represents. So they represent a range of numbers. They represent the bin that we're talking about here. So the width matters on these things. The other thing is you notice on a histogram, all these bars should be touching versus on the other one where there are categories. It doesn't make sense to have the categories butt up against each other, right? But when we look at these numbers, this is a continuous scale that is happening here. So if this is a continuous scale, I'm going from this one to this one. There is no gap between 74 and 75, right? There's no test score that you can make, but it's between a 74 and a 75. They're only giving whole number test scores. So we want these things side by side. They should butt up against each other. There should be no gaps on your histogram. We should have the x-axis labeled. We should have the y-axis labeled. We should have the appropriate scaling there. And we should have a title for our overall histogram. And so it looks like a lot of people scored. I guess this is low. It's passing. I don't know. But a lot of people scored in this range, right? In the 70 to 80. Not so many in the 80 to like 95, but a lot of people started picking up after 95, right? So it's kind of an odd distribution, but there it is. Not what you would want if you're assigning a test, probably. The following figure shows a time series graph of the overall death rate in the US from 1900 to 2015. Briefly summarize what it shows. Okay. Oh man, and I skipped over one part here. Make a histogram. The next thing is we want to make a line chart. So real quick, if I want to make a line chart, essentially what I'm doing is everywhere I see a bar between 70 and 75, I want it to be 5. So I want to put a point right there where my bar is. I want to put a point right there on top of where my bar is. I want to put a point right here on top of where my bar is. Same thing, bar by bar. I want to do a line chart. Trying to remember which one is called chart and which one's called graph. It's like always it takes me a pause. It's the same thing pretty much, right? And so we're going to draw a line. Get that line straight. Okay. And so that is a line chart then. So this is essentially what they did here. They plot it point by point. And they plot this across time. So if we plot it across time, then it is a time series graph. And so we want to see what this says about the overall death rate per 1,000 population. If we're looking at this thing in general, right? And so this is sort of goes back to like if you want to cherry pick your information, you can always just like focus in on one weird sort of feature. But in general, if you want to look at this thing, if we zoomed out, we would see that this thing is going down overall. So this is going down overall throughout the years. Which means, what about my death rate? It means that it's decreasing in general. So we're going to look at a bunch of graphs in the next section, just like this one. There are probably a few things that you could tell me that you should tell me. There's a few definitive things out there that you should definitely probably get down, like, hey, this is going down overall. The other thing we should really notice is probably this guy right here, right? That looks like something crazy happening there. And if you think about like what this would mean, we're looking at the death rate per 1,000 population, and this might be a little bit ominous, but this is comes from the 1918 like Spanish flu, right? So if you know your history, we had a influenza pandemic right around 1918, 1920, leading into 1920, I believe. That's what we're seeing there with that spike. So when you have a pandemic, your death rate per capita is obviously going to go up. And so that would be like the two sort of really key defining features here, right? Is that overall this thing is going down. It goes up and it goes down a little bit each year, right? But overall, sort of it's going down. The other thing I would notice that's a major feature is that spike. And that spike represents something that happened historically. We can bring in maybe context to what we know was happening around us to describe why that spike is happening. And that is the final example in this section. So I will see y'all soon. Take care.